已解锁，请取出话筒。Hello. Maybe we can wait a few more minutes. Seems only half of you are here. maybe we can start. Let's not wait anymore. Okay. So welcome to MIT 201, Mathematical Analysis 1. Correct. Right classroom. Okay. So I will start by introducing myself first because we are meeting first time, right? Never met you before. Okay. So my name is my last name is Me, and you can call me Seng. Yeah, you just call me Seng. I was graduated 3 years ago in Australia, at ANU, doing my PhD there. Undergrad there also, I was doing pure maths. Yeah, I'm doing research in pure maths, mostly on algebra stuff. Yeah, if you are interested. Um, and after graduation, I came to SMU. Yeah, then I traveled work here. So I worked here for around like 3 years already. I taught a lot of courses here, calculus, algebra, analysis. So this is the second time I taught it. And then Azure Algebra, you guys take Azure Algebra, right? And general topology, ME courses, algebra topology, algebra geometry. So yeah, a lot of courses I've taught. Yeah. So I have a brief idea on like what's your overall curriculum is. Yeah. So when I teach, I'll try to connect to those courses to give you some ideas. Yeah. But then, so I've you want to know other part of me? Okay, maybe I play badminton. I play music. Recently I play Wanzi also. If you're interested, can play together. Yeah. Do you guys play Wanzi? Honest, okay. No, okay, no, not for you. Okay. But then, do you have like other hobbies? You can't just do maths every day. Right? Yeah. So make sure you don't do maths every day. I scared you get crazy next time. Okay. Um. Right. So about myself, how about you? Okay. Why are you coming to MIT degree here? Any reason why? Because my parents forced me. No, not like that. Okay, maybe let me show of hand. Let me do some survey first. Uh, so everyone here understand Chinese or no? Everyone here know. Because I saw some non-Chinese name. You guys know them? Let me call some names. Ravelli Mumzekli. You guys know him? No. Seems like not here. Then others are Chinese, I guess. Either Malaysian or China. Okay. So maybe I do some survey so that I know how to teach you guys. So you need to be frank with me and be honest. So why are you here? Maybe can I show of hand if you're really interested in mathematics and see how much of you? 1, 2, 3, 4. Four. Yeah, it's okay. It's fine. This is very typical in a MAT classes one. I mean, like I have a lot of like, okay, my student graduate already. They do intern, right? They're happy. They're happy doing insurance, accounting, finance, or whatever. It's okay. It's fine. Although this class is a pure maths class, but then it teaches them to like think. You know what they do? They they teach their boss to do things. I mean, like she's like making an Insta story, right? Like complaining like the boss don't know how to do calculation, like don't know how to give salary, something like that. So she explained this part, have to go. Okay, how about the rest? What do you do? Yeah, what do you want to do in future? No idea. Okay. But are you open to learning? Open to learning? Good, good. Open to learning? Good. The rest? Open to learning? Okay, very good. Okay. I think this is the attitude you have to have. Okay. So whatever you learn might not be directly applied, but in certain way it will appear in your life. It not appear as whatever we're gonna learn later, but then it will help you to think, definitely, for sure. Yeah, this is for sure because I already see like lectures of my graduate doing this thing. And they say, oh, apply real knowledge to the real world. Apply knowledge to the real world. Something like that. So it's really useful, in particular when they work with their boss. So another thing I want to um, discuss with you is this is actually a very new style of this course. I'm not sure you've taken credit hour course before or not. Because this time is my first time introducing the tutorial class. So we're gonna break our class into 2 plus 2 plus 1 instead of 3 plus 2. You used to have 3 plus 2 class. Right? Well, do you feel tired in the 3 hours? Sort of. Yeah. I mean, I'm very tired. I'm actually very tired. Okay, so we also the reason why we introduce this tutorial class is also so that we can get to you closer, so that you get to do hands-on calculation, not just the lecture keep talking here. Okay, you understand? Okay. So at the same time, this tutorial, right, I also get some help from your senior actually, my students. So we could go around and look after you. Do you feel better? Yeah, right. Okay, so we could do discussion in that tutorial class. Okay, but I'll tell you in details how we're gonna carry that out. But then the problem is, this tutorial class they schedule on Friday, right? Is it on Friday? Okay, let's say we turn it to Thursday. Are you guys okay? You guys okay? Thursday? No, no, okay. So yeah, because tutorial become 1 hour, you used to have 2 hours lecture. You get what I say or not? So now it's like so today is day, right? So Wednesday 2 hours, right? And then Thursday 2 hours, right? And then Friday 1 hour. So I was suggesting that can we swap Thursday and Friday? So you do 1 hour on Thursday and then do 2 hours on Friday. Anyone got like objection or not? Because I need to ask AA whether we can do it. Do you have schedule clash or not on Friday if we do the 2 hours there and then do 1 hour on Thursday? No, okay. Everyone okay. Everyone okay? Okay. I need to ask AA first because they are very particular one. Yeah. If cannot, then we just stick to Friday. Okay. Yeah. Um. Yeah, but then for this week, maybe I have a slight how to say slight um what is 请求 request, yes, very good request. I got a slight request. Because we're not gonna start tutorial this week. Okay, so I wanted to do 6 hour lecture this week. Is it okay or not? Just for this week. So that we have enough material to start tutorial next week. Yeah, otherwise I scared not enough. Because this course is kind of tough. By the way, at this course is have a reputation that is a worst tough course. Even study in Australia, right? Like a lot of them is very struggling. Okay, so you have to prepare to struggle, but I'm prepared a lot of help for you. So you need to give me feedback. Okay, and maybe after each class you have to give me some feedback so that I can see how to adjust. Okay, no. Yeah, so this course is like famously hard. Because why is it hard? Mostly why it's hard, do you know? How is the definition of hard? What do you think? Usually something is hard, right? It's something that you never see before. It's hard. You never see before, you never experience it before, you never think about it before. Okay, so this course will have this kind of um, feeling. Okay, so I will try to like give you as many examples so that you try to familiarize yourself with. But then at the same time, also I need to make it like more accessible to those maybe not as uh, research guy, right? But then in this course, do you know what is IELTS? You know IELTS? Does everyone know IELTS? What is IELTS? English test, right? So what component they test on? There are 4 components they test on: reading, writing, speaking, listening. Okay, speaking, listening. Good. So this is what we're gonna do in our class. You're gonna read in maths, write in maths, speak in maths, and listen in maths. Okay, so you're gonna learn this after this class. Okay, you're gonna think like that. And listen in maths, reading in maths, writing in maths, and listening in maths. And this is what we're gonna do. This is a mathematics version of IELTS. So Say until this stage, right? IELTS is a language. Maths is a language. Please forget whatever you learned before. Yes, we're gonna learn start from 1 plus 1 equals. Did you make a question like, hey, you learn maths, huh? You learn maths, right? Do you know why 1 plus 1 is 2? You get this kind of question from your friend. Yes, right. We're gonna do this in class, in this stuff. And I'm gonna tell you why 1 plus 1 is 2. Okay, we will start there, and then we'll continue with the calculus 1 stuff. Yeah, function, continuity, algebra, and then interpolation. Okay. Yeah. Okay, you get the idea now? Okay, cool. So hopefully I don't make it too hard, but please give me feedback. All right. In this case, do you want to talk about course info first, or you are interested about maths in general idea? Which one you want to do first? I give you a choice. You want to know how to score first, or you want to know what you gonna do with this course? How to score? Okay, very realistic. Okay, very good. A typical SMU student. Okay, so I put the course info on your Moodle. Okay, so if you are not on Moodle, please let me know. I will add you in. Okay. Why I put on Thursday? Because you remember your timetable. I used to have like 2 hours, 2 hours, 2 hours. Is there any one of you like asked Pauline why is it 2 hours, 6 hours? So that's why she changed it. Any one of you asked? Because she changed it the Friday to 1 hour. Yeah. Okay, I thought I had freedom to choose, so that's why I picked a Thursday. But then my student also free on Thursday, so we'll see how. Okay. I have office hours, Fridays 10 to 11, 1 hour here. Or Wednesday, we can meet at the math study group. Any one of you join the study group before? No, you got one of you, two of you, maybe two, three. Or one committee here is it? There's a committee here, the student council committee. It's the student council committee. Okay, so I encourage you go to this study group. Okay, you can met senior, junior there. You can either get help or help people. I mean, mathematics is you need a discussion, you need a concept. You need to talk to people, talk about maths. Otherwise, you'll forget. Yeah, you'll definitely forget. You cannot just read it and then you think that you know it. Okay. Regarding textbooks, we've actually following this book very closely. Just realized by one of my students. So this coming books is what we follow very closely. I put out the PDF version of it. For the rest, Petrovic is good. Patrick is good. Okay, so these 3 books. And then for the rest, you can refer it as you like. As I recommend like why this book is important here. So you can try and have a look. Actually, this Ruding, right, is the classical book for analysis. You can try and challenge yourself and read it, but then maybe it's not readable for the beginner. Yeah, because lack of examples, and then the term is very rigorous. I mean, precise, very short. So you might not understand what it says. Okay, but then when times get over, we have these books. You can imagine 2021. I think I just entered PhD. So these books come very late, come after my undergrad. So I don't get help. I read this book. My lecturer used this 1976. So it's like very tough that time. But nowadays it get better already. Okay, so right. Cool. Okay, so our content is basically 5 topics. Okay, we will construct real number first. So we need to start with numbers. Okay, after numbers, we will talk about function between numbers. I think you see in calculus already, right? Function between numbers. And then we talk about limit and continuity. Again, it's the same. So you might think that it's the same as calculus 1. So what's the difference there? So we're going to use a different description of limit and continuity. I think you saw it before, right? Epsilon delta. But maybe you don't really know what's going on. Yeah, but that's what we're going to pursue in this course. So everything in this course will be epsilon delta. You cannot run away from it. So hopefully throughout this courses, you will know what is it doing. Okay. So very ambitiously, we wanted to do sequence and series of functions here, but then we'll see how it goes because we reduced our lecture from 15 weeks to 14 weeks. So we'll see how much we can do there. Okay. So about assessments, so because this is a 5 credit course, so that's why there's a project here. So we have assignments. So I try to give you 4 take-home assignments, and then in-class quizzes. So whenever the week we don't have assignment, we'll do quizzes in class. Okay, so this quizzes is inspired by my previous students. So they say that, oh, whenever I go to exam, I cannot do the question. I'm very scared. Okay, so that's why we practice. We practice tests. Okay, so we practice this quiz, but this quiz is very short. It's how to say, almost like giving you the marks. So it will be like an assisted quiz. So something like draw a line, fill in the blank, state wrong or right, and then maybe I give you a proof, find something wrong, something like that. It's not like the how to say long question because I want it to be short as well. So I just wanted to test your understanding. So whether you get the main point from last lecture or not, something like that. Does it make sense or not? It's like this week's stuff I will quiz in next week like that. Yeah, so the range is just the previous week lecture. Does it make sense? Okay, yeah. So I wanted to you to like pick main point from each lecture, and then I will test those in the quiz. Okay, and get the idea. Okay, the main point is not like to punish you or what, it's just to keep you on track. The main point that you need to understand. Okay, we'll see how it goes. Um, there are 2 projects I wanted to put here. Okay, one project is definitely like a extension of this course. So, but then extension of this course, I want you to find a mathematician, okay, that related to this course. Throughout this course, you will see a lot of mathematicians like Cauchy sequence, and who else? And then piano, I will meet piano axiom for natural numbers. And then Bolzano-Weierstrass theorem. So you meet some. So there's a lot of name. Okay, what I wanted to say is there's a lot of a name of a theorem that bears a mathematician name. So I wanted you to, if you are interested with that theorem, go and find that mathematician. Okay, find the background of this mathematician. So maybe find why, how he lead to this theorem. Okay. So this project is not like a very mathematical project, but I wanted to you to learn about the humane part of this mathematics. Yeah. So why people are interested in this? This is what you're gonna answer in this project. You understand? Because sometimes you just calculate, then you forget why you're calculating. Okay. So this is what I want you to do in this project. Is it okay? Understand? Maybe we can talk a little bit more about this content later on, but this is the idea I want you to get. Okay. So this is a humane part of this project. It's not about theorem proving definition only, but then I wanted you to learn why they are interested in this and what the main result they lead to with this. And because maybe they wanted to go to keep more, but then they end up with the total result, something like that. And total result become okay. Okay. And then second part is I found very useful is I asked my student to do revision. Okay, I want you to do systematic revision. Okay, so there's another project is revision and summary. So maybe I'll come up with a list afterwards. I will assign you to each lecture. So after every lecture, right, I will release a complete version lecture. So I want you to latex it. You know latex, right? Do you know latex? Yeah. I want you to type it out. Okay, in any form you like, whatever form. But then you need to follow my content. And then I wanted you to make a summary of it. Okay, so this summary could be like a flow chart. Like, or this theorem, go to this theorem, go to that theorem. So this summary is like, like most of you are from Malaysia, right? So you like, do you know like the SPN reference book? They will make a chart or a chart so that you can revise easily. So this is the thing that I want you to do. So you make a flow chart or you make a summary so that in the exam, you can pull that chart out and then you study very fast, recall things. Instead of reading my like maybe 500 pages of lecture notes, it's impossible, right? So you do summary and then write down the key point, write down the key example. Does it make sense? Okay. Okay. So this is the second project. Okay. We can talk a little bit more when we go deeper into the classes, but this is just to give you a rough idea what you're going to do in this course. Okay. Yeah. So hopefully this project will help you like appreciate this course and then learn better to guide you. Is it trying to feel very burdened already? Huh? A bit burdened. Okay, we'll see how it goes. Yeah, so question. Uh, let me think. Let me think. Sure, it's a very good question. So I was thinking like maybe 1 week after the lecture. What do you think? Is it reasonable or not? Okay, so one thing I want you to think about is maybe for week 1 to week 6, right? It will be included in the midterm. Do you prefer that it get done before the midterm so that everyone can share the resources? Resources? What do you think? Yeah, so okay. So the summary you make here, right? Obviously, you have to like make it accessible like to yourself and maybe your friend. Otherwise, why you are writing the summary? It's not useful. Okay, so hopefully these resources can be shared around you. Yeah, so that help everyone to learn together. Correct or not? You do one part, I do one part, we use together. Do you feel more efficient that way? Yeah. Okay. Is it 1 week or 2 weeks? What do you think? Huh? You can do that, but not everyone. Yeah, yeah. Oh yeah, yeah, sure. We definitely like avoid that. I mean, like we can't do that, right? You would have other classes to attend, right? Okay, so maybe 1 week after the lecture, what do you think? So for example, let's say you type lecture one today lectures, so then maybe next week you're gonna submit. What do you think? Make sense? Okay. If everyone agree, then we will make that a deadline. Okay, yeah. But I hopefully it's not a hard deadline for this. It's just that we want to try and keep it up with our exam. Yeah. So let's say our exam is like week 8. Have I decided my midterm exam? I haven't decided the content yet, but I think around there, I guess. Yeah, let's say let's say our test is on week 7, right? I haven't fixed this yet. We're gonna fix soon. Uh, then maybe the content is from week 1 to week 5, right? So if I request that people finish the revision on week 6, then everyone can study together the material week 1 to week 6. Make sense? Make sense? Yeah. Okay. Okay, then we'll make that a 1 week deadline and then see how it goes. Okay, so for project 1, I think we would have let's see. Okay, so there's a presentation part right here. So there's a presentation part. I feel like we don't need to present our project, but we just do tutorial presentation. Or do you want to present both? No. Yeah. So tutorial presentation would be like we do a group discussion, and then after group discussion, maybe in the last 20 minutes, we'll ask every one of you in the group to present. What do you think? Okay. Yeah. So we can make that a presentation as well. So we don't need to present our projects. Yeah, project is just as a project. Okay. Yeah. Okay. So for these things, we will update again. Depends on our pace. I'm not sure it's fast or slow or what, and depend on your result whatsoever. We will update you again. Okay. Cost info part. No. Okay. In my course, because if you shine, I cannot guess what you are thinking. So please let me know. Okay. In that case, then I want to talk a little bit before we really start our course, I want to spend a little bit talking about what is mathematics so that you have a better understanding or we have a same thinking. So what is mathematics? Well, um, well in Chinese, maybe you will call it 数学, right? Okay. So I want you to differentiate 数学 and maybe what we call is arithmetic. Okay, so what's arithmetic here? Maybe if you learn better in Chinese, this is called 算术. Okay, so we are more than calculation. Okay, in this degree here, we teach you how to think logically. Okay, how to argue logically. Okay, so this is mathematics. Okay, but mathematics obviously will include arithmetic. Okay, you have to prove people, you have to calculate the people to see. Okay, so this is one part. But then I think for primary school up to secondary school, you all deal with just arithmetic mostly, or rather, I would say you tested with arithmetic. We want to see your calculations right or not. Don't really care how you get the answer because I already fixed the method for you already. Understand? But in this course, it's really different. What I'm gonna teach you is principle. How you're gonna write it out is your way to write down. Okay, so you cannot copy answer one. If you copy answer, plagiarism is very easy to check on because the way of thinking is the same. So it's very easy to check. So I ask you, maybe you think that, teacher or Seng, I thought Max only got one answer solution, one fixed solution. No. Okay, I ask you, every one of you bath or not, shower, 冲凉啊，对不对？does everyone start with the head or not? Or does everyone start with the body? Or you start with shampoo? Different, man. Correct or not? Everyone bath but use different way one. Okay, so this is what you're gonna see in this course. Okay, yeah, it's very free. Okay, so this is about mathematics and arithmetic. And so in that case, let's talk about mathematics. So what is mathematics? So basically, we will spread this mathematics into almost three parts. Okay, so first is pure, second is applied, and third is about maybe statistics and finance. Okay, so for the pure part, what I've just done last short sem was number theory. Okay, and analysis, like what we do now. And the other course you take algebra. And you go, actually, inside analysis, you will see geometry already, like calculus, geometry. And then if you want to go further, you will make something called topology. Okay. Even for these branches, there are like more branches. Like in number theory, we split it to like algebraic version or analytic version or the usual classical one, like the one you take in your short sem. Yeah. So there are a lot of branches that I would like to say here. For applied one, you have certain courses like in this. So maybe I can introduce some courses in SMU and you, so that you have an idea of what ME you could take in future. Applied one, you can consider like combinatorics, dynamical system. And are you guys doing PDE this semester? No, maybe next semester. Okay, this semester don't have. ODE you guys did already, right? Yeah, okay. And then maybe in later year, you can look for this stochastic stuff, stochastic analysis. Okay. And statistic, you have learned statistic, obviously. Okay. Maybe probability, right? You also learned it. Is it this semester? This semester statistic? Okay. And then economic, I think they are like macro here. Okay, you could take. I saw my student taking. Obviously, there's a financial max. Okay, if you wanted to go to finance area. Okay, so there are finance 1, 2 here, but at the moment there's no one teaching 3 yet. Not enough stuff. Okay, so these are the future direction you could have when you are studying the courses in mind. Okay, so if you are interested in pure max stuff, right? Pure max, there's a lot of direction here. For example, in geometry, we also have algebraic version and a differential version. Okay. So you can see that actually most of these courses are they break into like analysis part and algebra part. Yeah. But then I would say that the most undergrad courses here are very crucial if you want to do pure maths research. You need to learn both algebra and analysis because in the frontier of research, right, these are just very basic stuff. Yeah. Although I would say that this course is very hard, right, very tough, but then for them it's like a baby, yeah, baby course. But I admit that it's very hard. Baby is hard, right? Baby cannot work at first, right? Baby cannot eat. You have to bring the baby to the breast or the milk or the food. Okay. Yeah. Okay. But I wouldn't say that they are like any one of them is superior over the other. Okay. Because in the end, if you really want to do research in these things, right, these are very pure stuff actually. Yeah, I remember like my friend doing statistics, PhD in statistics. They use something in like differential geometry, or they use the central limit theorems, right? That do you guys know central limit theorems? Are you guys introduced? Yeah. So they prove it in the higher dimensional case using the differential geometry, like Riemann geometry, something like that. Okay. So I don't say that any one of them is superior than the other, but then I'm just trying to introduce more on this side because I'm from this side. But then I can try to give you idea on the other side based on my interaction with the rest. Okay, so far have a better idea on what you are doing. Okay, cool. Okay, maybe can have some nice picture to show you. So this is basically the mathematics landscape. So it's algebra, topology, logic, whatever. Yeah, but then category theory is what I did on. Okay, so hopefully we can describe everything in terms of category theory. We did this in graduate algebra actually. I'm teaching graduate algebra this semester. Graduate algebra only open for master, unfortunately. But if you are really interested, you want to sit in, it's okay. You can tell me, I can let you know the schedule. I think, I'm not sure you see this meme before. Mathematics trash. I think it's appear in Red Knot as well, Xiaohongshu. So these are the topics that you can see in mathematics. So you can fall off forever. There's a lot of things to study. Yeah. Okay. But not in this class. No worries. Not in this class. Yeah. But then if you want to go in future, the path, then you will see all these things. Yeah. In particular, these are where stuff happenings now, actually. Yeah. I mean, I'm using one of them at least. Yeah. By the way, yeah. So maybe you are just here yet. That's fine. It's already very good. So I will give this picture to my students every time. I admit that max is hard, okay, but then hopefully throughout this week, okay, now maybe it's not 15 anymore, maybe it's 14. Okay, throughout this week, you can see a nice picture of mathematics in the end. Okay, yeah. Okay, so about my class, so these are the 4 principles I hold on. So if I violate any one of this, you can reprimand me, you can scold me. Okay, so I focus on freedom, make sense, rigor, and clarity. So if let's say something I say is not clear or not rigorous, doesn't make sense, you can complain to me. Okay, I try to make sense to you so that you know what am I doing, you know what you're doing. Okay. Okay. Yeah. Okay. So very frank to you. So please be honest with me so that I know how to adjust. Okay. In that case, right. Okay. So maybe introduce something about my class, or can we get class rep actually? Do we have class rep here? No. Anyone want to be a class rep? Maybe I can get a girl and a boy. No, no one. Okay, so what this club thread have to do for me? Maybe sometimes I have urgent announcement. So club thread have to be like vigilant to my announcement or what. Then because you guys are always in one class, right? So they can like inform you immediately. Do you guys have a class WhatsApp or whatever? Or WeChat? Got is it all of them there or just partially there? Not sure. Okay, never mind. But then because you guys are in one class, right? So maybe it's faster to like commute within your class. You take classes every day, right? For now at least. Most of your classes are the same. So you're gonna meet most of the time. And also sometimes you don't want to, so maybe your friends or your colleague is scared of me, don't want to talk to me, then they can talk to you and then you can talk to me. What do you think? Huh? Anyone want to be a classmate? No, very scared. Scared of me. Huh? What do you think? Interested? Interested? No? No interested. No one interested. None of you. Wow. Okay. We'll see how. Mm, let's see how. Okay. Right. See. Yeah. So okay. So before that, my class would be like lecture plus tutorial. So we have tutorial in class, but then now we try to split it away already, so we will have less guiding question on classes. But then this is the flow that I'm gonna present to you every time. Yeah, and then I put color inside my notes so that you, when you want to find for a certain theorem or definition, easy to find. Okay, you just look for that color and then you find it. So basically, when I teach something, right, I will start with motivation. I'll start asking you a question or recall whatever we have learned before. And then next, we'll introduce definitions, introduce new things. And then after introduce new things, I will tell you what example it works. Okay. And then we'll start exploring the properties. So these are the theorem propositions. And then I'll prove it to you. Okay, so this part is pretty important in this course. Okay, we're gonna spend most of the time studying proof, writing proof in this course. Okay, so you will learn how to prove to people. So maybe boss asks you why this works, why this doesn't work. You have to prove to him. Okay, for example, Peter is my boss, right? I have to prove to him. Doesn't work one Peter. You know Peter? You guys know Peter? You know Peter? Yeah. Okay, sure. Doesn't work. Peter, this one can work. Okay. Like that. Okay, so this is how we're gonna use proof in our real life. So either you use direct proof, contradiction, or contrapositive. Have you guys seen this word before? Okay, maybe you've seen this word before, not familiar with it, but after this course, you will be very clear about it. Okay? And then 6 is about notation, okay, or remark, some terminology. Yeah. So comment on what we have learned. Yeah. So this is a bit like a summary or after reading stuff. Okay. So this is trying to explain what these proposition is used for. And then 7 is maybe some my extra my point of view, POV. Yeah, my point of view. So maybe you could have your point of view also. Then you can include in your revision question, the project. Yeah. So maybe you have your own point of view. Because point of view sometimes it's not wrong. It's just apply in different cases. Or yeah. Okay. So far so good. Okay, so whenever I say things, most of them will fall into one of these 7 categories. Okay, so whenever I say one thing, you should think whether I'm proving it or not. Is this statement true or not? Or am I just giving you idea? Okay, so basically, this is the 4 I'm going to introduce. Okay, understand. Cool. Okay, I think we still have like 7 minutes. Okay, so before we break, let's play a definition game. Okay, do you have papers? Do you have papers? Or you iPad also can? Okay, iPad also can. So let's play a definition game. So definition in this class is very important. So let me define something for you. Can you get out your paper or your pad that can draw? Okay, let's play a game. So let's define. I think everyone know bananas, right? but then I'm gonna define this way. So banana is a big, red, round, sweet fruit. Okay. So I define banana. So can you draw a banana for me? Yes, please draw it. Please draw on the paper. I give you 1 minute is enough, right? I give you 1 minute. Anyone not know any English word here? Big, what is big, what is red, what is round, what is sweet? Yes, very good. Define big. What do you think? Very good. Very good. Okay, I let you use the big you like. Yeah. Okay. Draw it. Yeah. Make sure you can explain to me what is big later. Okay. Please draw it. I use your reason. I'll use your reasoning. Okay. Maybe I give you another more minutes. Okay. Please show me your banana. Can you show me your banana? Like, show me your banana. Like, hello. Can you show me? Oh, I mean, you like show this like this. You do this. Like, show your banana to me. Your hand in your banana. Wow, very round, very big. Very good. Can everyone show your banana? Please show a banana. Everyone. Wow, good, good. Wait, same banana. See. Wow, wow, interesting. That one is very interesting. Wow, good. Good, very good. Good. Okay, good. Can see. Everyone see. I want to see your idea. I don't want standard answer. How about the back? The back. Show me. Send in your banana. Wow, good, very good. This is like all around. It's okay. But let me see. See. Oh, good. Oh, yeah. You add your own green part. Okay. See. How about the rest? There. Your PAD banana. Can you show me? I want to see your PAD banana. Huh? What do you mean? Not thick enough. Okay. How about the rest? What? Why? Why?
Because then it's round.
Why is it round?
And you have Q2, right?
And then
You have Q2
and then why is it round?
and then I define a unit sphere to be round and then around something round is to be unit sphere. So you take the absolute value, create the absolute value on the Q2 space and then you
What's Q2 space?
grading numbers and
What's PAD number? Define PAD number for me.
firstly you confirm so you define the MC set your reactions
Okay.
and then blah 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 and then you define the next number set is very tedious.
Okay. So tedious in this course, every tedious stuff have to be written up. Okay. So you cannot just say, oh, like that. No. You have to be rigorous. Everything need to write out. So another thing in this course is almost everything will make it a lemma and prove it. Anything we're not sure, we will make it a lemma and prove it. This is the point of this course. We won't skip any proof. No proof will be skipped. Okay. Yeah. Okay. Can I see the second row banana? I see your banana. Second row. Can I see your banana? Can you show your banana? Can you see? Oh, very good. Oh, good. Can you see yours? Hello. Can I see yours? You don't draw your paper? You didn't bring anything? So how you gonna study? Please bring paper next time. Okay, we're gonna do quiz in class. So you have to bring some pens and paper. I mean paper, maybe I can provide, but please bring pen. Okay, we're gonna do quiz in class. Okay, so I think there are kind of 3 types of banana. Maybe you can show one of you. You show one? Yeah, just show all of them. Show you. Yeah, show your green part. Show your green part. Hello, hello. Can you show your banana to them? Yeah. Anyone differ from these three? Okay, so um, maybe the banana that I think of it is something like this. Okay, just big, round, red. Maybe sweet. I cannot draw a label. Sweet. Okay. Yeah. So a very good question from your friends. I actually need to define what is big red for you actually. Yeah, but then if I don't define it, actually I meant to be like usual English. So what people think about big, that's the big. What people think about red, that's the red. Okay. But then I understand that you guys have the idea of real banana in your mind, right? So you have an idea of real banana in your mind. So you cannot resist drawing something like this. Yes. I understand. But then in this course, you need to be careful. When you have an idea on the term itself and what it get defined is very different. Because what we're going to use is everything behind the definition. It's not how you see this term. It's about how we define it. Okay, so everything come before, after is very important. Or before is, because sometimes we say that a big red round sweet fruit is called a banana. So everything before is important. So what I wanted to say in this class, name terminology is not as important as the description. The description is the most important in this class. Okay, name is just a name. Name could help you to understand the description, but it's not the description itself. You understand? Okay, so please be aware of how you read definition. So whenever you see this term, this is the term that I'm going to define. What comes after it is super important. Okay, that's the term that defines this term. You cannot say, oh, I think banana look is this way. Okay. So in this case, let's say in real banana is like this. What does this tell about this definition? This definition could be wrong. Definition can be wrong. Definition could be wrong. But then, is there a red banana in real life? Have anyone see red banana in real life? You see, right? I also see. I actually come from a village boy, actually. So let me show you the red banana. I mean, you can Google it also, but I will show you. Yeah, there's a red banana actually. Actually quite fat also, quite thick. I ate it before actually. So that's why I know. Yeah. So mathematics, another thing about mathematics is go and experience. You need to go and experience things. You need to feel what is 1 plus 1. Hey, how do you learn 1 plus 1 actually? Did you learn from your father or your mother? Your kindergarten? What's your first time learn about numbers? What do you think? Can you recall or not? Huh? 20 years ago? Okay, good. Yeah. For example, I think I learned from my parents. Maybe they say, oh, this is one apple, this is another apple, so you got two apple like that. 1 plus 1 is 2. Yeah, maybe you think about how you learn number at first. Yeah, it's true objects. Okay, it's true object. It's not like your one write down 一加一很 like that. No, it's not like that. Okay. Okay, it's not by arithmetic, it's by objects. Okay, so before we take a break, let us do one more thing. So my viewpoint on truth. So what's about truth? Okay, last thing we do before break. So let me ask you, what is truth? So let's say which equation here is true? Maybe are true. I let you think about maybe 1 minute or so. So one is 1 plus 1 equals 2. 1 plus 1 equals 0. 1 plus 1 equals 10. 1 plus 1 equals 10. So tell me which one is true. I'll give you 1 minute to think about. Okay, so anyone want to guess A? Those who don't raise out your hand, you think it's wrong. 1+1, not you are not earth people. What do you think? 1+1, 2 or not? No. Huh? Oh my goodness. I don't know, 1+1 is 2. Okay, so 1+1 is equal to 2 in this class. So by definition of 2. Huh? Sorry? 1+1, yes, legit. Yes, legit, yes. So it's a definition of 2, yes. Okay. Okay, so this is the definition of 2. Okay. Okay. Wow, I think quite challenging teaching this class. Challenging. Yes. Yes, that's right. SS0 is 1+1. S plus is a +1. What do you mean? Yes. That's a 1+1. Yes, I'm gonna prove to you. Yes. Well, teaching this class is kind of challenging. Because you will twist the truth. It's very, yeah. I mean, this is a real world problem. There are people twisting truth in this world, so you need to be careful. In particular, if they are your boss, you will be crying. I tell you, you do the correct thing, but the boss tell you this is wrong. So who you gonna follow? You're gonna follow the truth? Are you gonna follow your boss, or you gonna follow yourself? Follow the money, correct? That's true. That's very true. So most of the people they just follow money. Both say this, do for boss. I keep one my eyes. Yes, that's very true. That's very true. So you want to hold on your principle, or you want to follow the boss? You need to think about that. Okay, so 1+1 is 2. No objection. Okay, in this class, 1+1 is 2. I'm gonna show like what your friends more. X plus Y is a 2. We're gonna do that very soon. Okay, so this is true. Second, anyone want to bet this is true or false? True or false? You bet true? Yes. Maybe you can tell me why is it true? That one? Very good. So this is like in the elementary number theory, right? But then we will write a triple line instead of double line, right, in that course. Okay, so in mod 2 sense, this is true also. How about C? True or not? Right, binary. Very good. Okay, so this is your binary expression. Lastly, true or not? Can it be one? Where?
What one?
Mod 1 is kind of boring. Legit, but it's boring. Can we have a more interesting one? Huh? Good. Okay. So it's what we call a Boolean algebra. Yes. Go and check back your Boolean algebra. So what is the moral of the story here? The moral of the story here is, how do you interpret this equal sign? Where do you interpret this equal sign? It's very important. Okay. In different world, the 1+1 could mean different things. Okay. This is what I want you to see in this course. Okay. So you need to be very particular. When you write down equal, what does it mean? Okay. Yeah. So we're going to define every single symbol in this class. Cool. Okay. Okay. So I think we can have a break. Let's break for 10 minutes. We'll come back in 10:08. Yeah. Do you guys know which group are you in yet? Don't know. Groups here, I need to like open up two sign in code for you to sign in actually. Yeah. Okay, never mind. We'll do it. Everyone start sign into the class, or do I need to give you a code? Need code? Huh? Uh-huh. Yet already, but I mean the attendance. Have you guys started online attendance taking in your course? Do you always need a code, or you can sign in yourself? You need a code. Okay, okay. So I will generate now. Because okay, never mind. So this is one of the code. Let me generate another group, the code for another group. This is group one. Generate group two. If you cannot sign, you have to let me know. Okay. So let me also put this aside, side. Okay. I later I will put out the name so that you know you are in group one. So the right hand side is group one, on the left hand side is group two. And start signing. Your AC got group one, group two, right? Don't have. Can I see your AC? Your AC system. Oh, got right. There's a bracket beside your MA1. There's a group one or group two. Do you have your AC? You don't have to. You have to go to your basic info. Go to your. Yeah, you can go to your course list and then check you are in group one. Excellent， 我没有 excellent， 就是 excellent。你刚刚也是 excellent， 我听到 excellent， 我点的 excellent， 我差不多，okay, what? You guys successfully enrolled? Good. Okay. I think you have to use code. Yeah, I mean, like, can you use the QR code? You mean this one? Oh. You use the apps, right? WeCom. Use WeCom. Maybe like the small sugar. Yeah, you use WeCom. Everyone got signed in yet? Anyone failed? Still going on? Still trying? Does it work? No? You need help? Maybe? No. Because later gonna start class. You can you ask your friend? Maybe friend help him. We come. Does it work? Why? What happened? Can you see? Can I see? Can I see? Oh, it doesn't allow you to find.
One is I just want you to
But generally already.
but no it's oh my god.
Or the event is then for this one also
Yeah, wait. This one one and so one.
Okay, maybe for those who signed already cannot. Okay, let me click again. Let me see how it works. Let me click again. Let me refresh it. Let me refresh it. Yeah, new things is like that one. Would have problem. Ooh, complete though. Wow, no wonder you guys cannot sign in. Why suddenly complete one? Edit sign in. Sign in duration. 60 minutes. Confirm. How about this? How about this? Group 2. Group 2 can or not? Group 2 in progress now again. So next I want to start group 1 as well. I'm not sure what happened, but it becomes complete. Group 1 can, group 2 can start sign. Group 2. Okay. Yeah. And group 1. Okay, wait. So group 1 is here. 4760. Where's the ？Where's my take some time? 4760 group 1. Don't disappear. Group 1. Okay, a new code for group 1. Yeah. Wait, make it smaller first. Disappear again. Everyone successfully taken yet? Let me throw this one out. Oh, yeah, this one. Who's successful? Maybe I check who's successful already. None of you. You, one. One only. Only one successful. Okay. Maybe at the same time, also take the manual one. While you're trying this, I will take a manual one so that I can update it myself later. Zhang Henyu here or not? Okay. Zhang Henyu. Dan Jun Han. Chong Yu Eng. Liu Chunxiang. Chunxiang, okay, sorry. Tai Zhe. Okay. Ang Huijie. Huijie, okay. Ang Jingyi. Ang Jingyi. Is it you? Ang Jingyi? Ang Jingwei, sorry. Ang Jingwei. Chan Jiqing. Chang Wenwei. Okay. Qing Hang Yi. Qing Hang Yi. Lim Yi Heng. Okay. Raveli Mungzi. Okay. Chong Cheng Wei. Chong Cheng Wei. Chong Cheng Hui, Chu Yu Shen, okay. Helen Lee, okay. Ong Hong Jun, okay. Paul Yong Sun, okay. Xiu Shihui, okay. He Tian Li, Tian Le, okay. Lao Qiyang, Lao Qiyang or Qiyang, how do you pronounce your name? Qiyang, okay, good. Lim, yes. Lim Ping Jie, okay. Liu Chang, okay. Yuan Haoran. Okay, good. Not successful. Okay. Never mind. We'll try it again next time. The system, maybe I need to give some feedback. So what did you see in your apps?
No, my one is different from others. Their one can get scan one. My one,
Okay.
my one have no.
You can't just. Are you using WeCom?
Same app.
Same apps, okay. So do you have classes today? You go to my class.
Oh, okay.
Yeah. So anyone successful? Only one, two successful, 3, 4, 5 successful, 6, 7 successful. Can you tell people how you success? How you success? Type the code. What the rest do? Those who fail.
This one is the sign code or the class code.
So the class code is the generating code or what? The class code you fill in the generating code, is it? Yeah. So who failed? Here. So what did you do? What do you mean you don't know? You must see something, right? Okay, anyone scan and then invalid, so what do you do? Yeah, so try help each other. Who else failed? 有人不能吗？不成功啊？你们可以吗？你们两位 ？OK 啊 ，Good OK。那位呢？那个恒玉啊，恒玉 OK，you successful OK good。Anyone still fail? Yeah. You can try and get help from your friend. Those who success.
My one is quite different.
Quite different. Should be similar, but
Your company has a level what the hell is
can see who fell again. Who fell? Who not yet? Some already that side. Yeah, already. Okay.
Yeah.
Anyone haven't?
I think I almost successful.
Only you. Okay, you try. How about the rest? Got it. Good. Okay. So you remember your code? I'm gonna close this down. Which group are you in? You group 1 or 2? Okay. 3618.
No.
1. Oh, 2769.
Oh, okay.
1 or 2? 1 or 2? 2. Okay. 23618. So I'm gonna close this down. Okay. So if you haven't signed in, please get help from your friend. Yes.
They say that it's not yet.
Okay, let me refresh it again. Okay. I need to refresh it again. Group 2, right? Oh. Wait. Group 2. Group 2 in progress. Okay. Group 2. Okay. Generate. Okay, here. Nice. Okay, I got someone in already. Good.
The
6469.
Yeah.
Group 2. Anyone haven't? God, please sit down. If haven't, you raise out your hand.
Yeah.
Okay, good. Okay, I'll check then. I'll check your record later then. I have a manual one as well. Okay, so let's start a real business now. Okay, let's start new business. We'll start very simple. We'll start with reviewing actually something in your discrete math, but maybe a bit quicker. I think for the rest that come late, right? So we decided that we have 6-hour lecture this week. So please come for every hour in your timetable. And then next week, we're going to start tutorial. Okay, so next week start tutorial. So for this week, come for the 6 hours. Okay, I will do lecture. Because you can, as you can see, we don't do lecture in the first hour. Okay, so we'll do a review on max logic. Okay, let's start very simple. Let's start from statement. Okay, we'll do first order logic first. So let's do first order logic. Okay, so what's logic? Maybe give you a brief intro. So logic actually is the study of methods and principle. Okay, so used to distinguish good or from bad things. Good could means like correct or true. You don't need to copy my notes because I will give you notes later. So what I wanted you to do in my class is you have to listen very tentatively, understand what I say, because I'm going to provide everything after the class. So you just can read afterward. But then you can jot down whatever note you like. But then make sure you understand what I say. If you don't understand, you have to ask in this class because this is the point you come to class. Otherwise, you just watch your YouTube video is enough. Watch from your Indian guy. Is it Indian guy? You learn maths from Indian guy. My friend said learn from Indian guy. You don't know? You don't know the job? Okay, never mind. Let your friend show you the Indian guy later. Okay. So logic is something that discern like how to distinguish good and from bad reasoning. So one thing about reasoning is you have to listen what people say first. You cannot just blah 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 then argue with people. You listen first what he says, is it correct or not? You check and then you try and argue. Okay. So what is logic in a picture of sense? So in this class, I'm not going to teach you numbers on it. I'm going to draw picture. Okay, we're going to understand these epsilon delta stuff as a picture. Okay, so the max I do also come with picture. Okay, so we'll combine geometry and numbers together. So in plain picture, right, what is logic? Actually, logic is the bridge that connect 2 points. Okay, this is okay. We're going to tell you why this implies this, why that implies that, and then this is proof. Okay, yeah. Okay, so this is what we're gonna tell you. Okay, so before that, we need to get our statement right first. So let's define something called a sentence. So sentence, so this is what we're going to define. So I draw a line here. This is something that you don't know. I'm going to define something that in terms of you know. So a sentence, so we start with sentence. So every time you mention something, it should be sentence. Sometimes if you speak with friends, it's not a sentence. It's a hanging sentence if you recognize. Okay. 你吃饱了吗？饱了。It's not like 我饱了。There's not a full sentence. But then this is the informal way. Okay. But then in mathematics, we want it to be a sentence, full sentence. It's a complete statement formed according to the rules of grammar. Okay. So you need to abide to the rules of grammar. So for nowadays, I think the research in mathematics is kind of grow up in China. So they use Chinese also. And I think they Gaokao and then or their undergrad even, right? They're actually using Chinese tests already. So it will abide to Chinese grammar. But for us, we abide to English grammar because we are using English. Okay. And make sure you are communicating meaningful talks. Okay, it's not like rubbish stuff. Okay, so it should be meaningful. So for a sentence to work in mathematics. So maybe you will have some how to say dilemma here. So he's saying you define sentence as statement. Statement isn't it a sentence? Okay, so this is the place where logic happens. So I mean like definition could change this. Where do we start actually? Where should we start? So we should start from some consensus point. Okay. So let's say statement is something that we agree on. It's like very usual thing, life thing. Okay. So this statement is like an English term. Everyone should know what statement is. And then this max is the this sentence is a max term. Okay. So when we talk about sentence in mathematics, where it should be something that we already know. Okay. Yeah. We should have to start somewhere. So we have to start with something that everyone agree on. Okay. Cool. Okay, sentence must abide to grammar, and then there's some meaningful thought there. Okay, so maybe I give some examples. So, first example is who you, and then second is who are you, and then maybe third example is SMUM is located in Sepang, and then four is every number greater 1 is, okay, maybe I use shorthand notation, less than 1 million. Okay, maybe out of this 4 sentences, I mean, out of this, I cannot say sentence yet. 4 lines here, which one is sentence? Can you tell me? And if it's not, tell me why is it not. So is first one the sentence? No, okay, because the grammar wrong. Okay, so if you put a proper grammar, it should be who are you? Okay, at least we need to put a R. Okay, so first is not a sentence because the grammar is wrong. Yeah, I said as the grammar is wrong. Okay, so the second one is okay, full sentence. Okay, it's a question. How about 3? Is it a sentence? Very valid, right? Is located in Sepang. Okay, places I put in. 4, is it a sentence? Sentence. You got verb, you got gram, you got nouns, right? Valid sentence. Okay. So make sure when you write down the sentence, make sure it's valid. Okay. Then second. Second. So a bit confusing stuff here. I'm going to define statement. Okay, so this is a mathematics statement. Okay, it's not an English statement. Okay, so this is a mathematics statement. So what's a mathematics statement? Mathematics statement is a sentence. Okay, sentence is like grammar, everything good. But this sentence, we should be able to say it is either true or false. Okay, so this true and false is like English true false. You should know what is true false in your mind, right? You know what thing cannot do, what thing can do, right? Okay, but not both. Okay, does it make sense? So statement, yes, yes. Okay, cool. But not both is you cannot be true and false at the both same time. Yes, but the statement itself, you should be able to say true or false. It cannot be true and false at the same time. It's like a Schrodinger cat. So that is like
is up. Is up.
Yeah, so like this kind. So for this kind of statement, right? Okay. Sorry, that sentence actually has an exception, because in the reality, right, there are people that have both sexual organ. There are people like that. Bisexual. No, that's not bisexual. What bisexual means? Bisexual is like attract to both. But then I mean, like, biologically it will have like max organ and male organ and female. Did you see the news before? Never seen? You never see me? Okay, I'll show you the news next time. Okay, I'll show you the news. Actually, these people is like OKU, pretty chat. Yeah, a bit chat. Okay, never mind. But then the statement is a sentence that is true or false, but cannot be both. So let's see examples. Okay, let's see examples. Okay, so for question like first question, first statement. Okay, this is not a sentence already, so no longer statement. So you must start with sentence only. You can tell whether this is a statement or not. So second one, is this a statement? Can you tell true or false? Cannot, right? You cannot say true. Who are you? False. Okay, so this is not a statement. Okay, so this is not a statement. But then SMUN located in Sepang, is it a statement? Can you decide whether this is true or false? Can, right? You go Google Map find, or you go address find, got Sepang or not there. Okay, so this is a statement. How about 4? Is this a statement? Because it's a sentence, right? Is this a statement? Can you decide whether this is true or false or not? Huh? Can you decide? You can. How do you decide? You go and test, right? You go and test. Is it true that every number greater than 1 is less than a million? Is it true? False. Why? What do you think? Why is it false? Good. You found a counter example. Okay, you found a counter example that 1 million and 1 is greater than 1, but not less than 1 million. Okay, so this is false. So when you want to prove something is false for all, right, you need to find a counter example. Okay, so counter example is like 1 million. And for the previous ones, is true because you can go and check your Google Map, or you can check your address. Okay, does it make sense? Okay, you see something that's not, it's a sentence, but it's not a statement. Okay. Okay, cool. So for this true false thingy, so we will say that these are the truth value. Okay, so how true is it? So these are the true value of a statement. Okay, so we're going to define the mathematical true and the false. Okay, so this is something you learn in Boolean algebra also, right? In your discrete, in your O or the gate. So we will say that the statement, true statement of the statement is true if the statement is true, and false if it is false. Okay, so 1 is the max false, 1 is the English false. Okay. So far so good? So far so good? Okay. Okay, good. So next notation is there's some notation. We're going to use like P, Q, R, S using the letter. So these are the letters. P, Q, R, S. To represent a statement. Maybe sometimes my handwriting is a bit messy. If you cannot recognize, please let me know. I can correct it. Because sometimes due to time problem, I just scribble a bit. And then we will use a capital letter T for true, and then F for false. Okay. Does this match your practice in your discrete map? Okay, good. All right. Then we have statements, right? In mathematics, you have an object. Then what you do next? You're gonna combine objects. Okay? You're gonna combine and then see you get new stuff or not. So similarly in statement is like this. Okay. So next we're gonna introduce something called a compound statement or a composite. Okay, so this is a combined statement. So how do we form these statements? Okay, so this is again a statement. Okay, very important. So once I compound it together, I still can decide whether it's true or false. Okay. These are the statement how to form. Okay, form for using form from the existing statement. So I think this will help you recall some of it using the logical operation. Okay, do you still remember any logical operation? What? O and okay, good, very good. So you can start with negation, right? And then N, O, okay. Anything else? Conditional? By condition. Yeah, sure. XO. Okay, and if only if. Yeah. There's more advanced one. What XN, right? But then we seldom use those in this class. Yeah, we will typically deal with this. Okay, negation and or if then, if and only if. Okay. Okay. Right. So next, we're gonna define what is definition is. Okay, so this is a very important definition. So okay, so you can see that before I even define definition, I'm using definition already. So I'm kind of like cheating here. But now I'm gonna tell you what's definition. So what does this DEF means every time? Okay, a definition here is actually an unequivocal statement. Okay, so meaning you cannot challenge it. This is like a constitution of your country. You can, I mean, you can change it with majority, but then once it's in there, it will rule out every I'll say the ruling in the court. Yeah, constitution is greater than every rules in the country. Okay, so this is like the constitution in mathematics. So definition cannot change unless you build a new definition. You can say that this definition is useless, but then you cannot change it. Okay, so it is an unequivocal statement of the precise meaning. So like what I told you just now, the banana examples. Okay, so the description is very important. Okay, no matter how you think about banana, but I define banana like that, then that's the banana that I'm talking about. Okay, it's not the banana inside of mind. Okay, so it's the precise meaning of a word or a phrase, a mathematical symbol or concept. Okay, it's a precise meaning of these things. Okay, so like what your friend always like to ask, right? To end all the possible confusion. So if you have any confusion about definition, well, you need to try and list down your confusion and then see and compare. Are you right? Am I right? Or something's wrong? Something extra I think about. Usually it's something extra you think about. People will say that, oh, maths is hard. Why is it hard? Then I go and check. Why is it hard? Oh, you think of the wrong way. That's why cannot work because you already start with wrong definition. For sure cannot work one. Okay, so everything in this course you don't know, go back to definition. Find the word, go back to definition, and then work from there. We have no other second road to go. No. Okay. Go back to definition. Okay. Okay, next. So I tell you what negation, stuff like this, right? Let's recall a little bit. Okay, maybe we just go through without writing. Seems like you guys are quite happy about this. Okay, so what's negation? Well, so the true value. So we're gonna define. So the negation. Let P be a statement. What's the negation? Negation of P. We'll write it as well. Square. Is it square? How do you call that? Dash P or tilde P or this thing of P is the statement that it is not the case that this statement happened. Okay, so let me give you an example. So let's say just now we have a statement SMUN is located in Sepang, right? What's the negation of it? It is not the case that SMUN is located in Sepang, or in the plain word is SMUN is not located in Sepang. Okay. Or another example is every number greater than 1 is less than 1 million, right? So it is not the case that every number greater than 1 is less than 1 million. But then, how do you turn that into a negation? Do you say that every number greater than 1 is not less than 1 million? No, that's not the negation. So the negation is that is some number greater than 1 that's greater or equal to 1 million. We will teach this quantifier later. Okay, so why negation of a for all become there exists? But then this is how you prove that it is not true, right? You remember, you just found one number only. You didn't like say that every number have to be greater than. No, you just found one number. Because you just say that everyone have to be true. I only found one is false is enough to. Okay. Okay. So later we'll go into quantifier again. Okay. But then this is the notation, not P. So the true value of not P is opposite true value of P. So this means you can draw out the truth table. I define what is truth table. So let's say your proposition is true. Like if I say that SMU is located in Sepang, if you say that it's not, then you are false. Okay, so but then if you start with a false statement, then if it is not false, it must be true. So it is opposite one. These two things. If T is true, then not P is false, and then if P is false, not P is true. Can you read this truth table now? Okay, got it? Okay. Okay. Okay, good. Okay, next is a conjunction, which is N. Okay, like what your friend said. And so what's N here? So N, so when you say N, so we define it using their true value. So N only true at one cases is when both of them have to be true. Okay, if either one of them is false, then it's false. This thing. Can you give me examples? That's true. And statement, that's true. Function. Can you give me one example? Give me one example.
0 equals 0 and 0 equals 0.
Okay, so this is a very trivial example because if you know that 0 equals 0 and then you just put two, I mean, same. Okay, we'll say this is trivial. Can you come with a non-trivial one? Maybe not mathematics. We haven't go into mathematics, right? Maybe you can use some real life example first. Both statements that's true put together. Huh? Not trivial, yes. Okay, good. We cannot verify that. All right, let's assume that's true. Let's assume that's true. Okay. So let's assume that's true. You are handsome, okay, true. And you are smart is true. So these two together is true. Let's say we agree first. Okay, we agree. Okay. We cannot verify it, but we agree first. Okay. Can you give me an obvious one that's 1 true, 1 false? Yeah, sure. Okay, can. Okay. Actually, are we gonna prove that next time? Let me see.
Wait.
Yeah.
It's very weird.
Weird. Yeah, weird.
Oh, okay.
Because they put the P and not P together. Let me see whether I'm gonna prove this later. Yeah, correct. Later we will see that. Can we give another one? Another very close to normal example. I wouldn't say you not normal but then you are trying to play with techniques. I will show you the techniques later. Can we do something like no? Okay. I'm not offending you. Something usual. Okay, maybe use your example. Let's say we agree you are smart and handsome. Then he is smart, but he is not handsome. Then this is false. Okay, good. Okay, settled. So disjunction. Okay, how about disjunction? So disjunction is all. All is kind of opposite with and. So all only true. Only false. Okay, only false when both of them are false. For the rest is true. Okay, so what this means? This means all has more like freedom. Okay, as long as you make sure one of them is true, then definitely true the same. You don't need to check both one. Okay. But then if you start with a false one, definitely you need to check the other one. But if happen that you found that one of them is true already, then the other one you don't care. Okay, so meaning or you can attach something weird, but then attach something weird to true is still true. So this one is some ambiguity you can play with. Okay, so far so good. Okay, so all for all statement of all only false when both of them is false. Okay. So this is very important in proof. For example, meaning if you want to prove some statement is true for all P or Q, you need to prove that at least one of them works. Only then it works. This is how we use this truth table. If both of them don't work, then this whole statement is wrong. Okay, makes sense. So N is very restrictive. If you want to prove a statement that both of them is correct, you have to prove both of them. Very obvious, right? Okay, if one of them doesn't work, then this whole thing doesn't work. Correct? Because you say both things works. Correct? No? Yeah. So this is how we think about this truth tables. So I guess this is the XOR your friend says, right? So OR, there's another kind of OR, right? Which is called an exclusive OR. Just now what we do was inclusive OR. So exclusive OR have this property is you cannot be true and false at the same time. Can you think of a daily life? What do you think? Yeah, sir.
I don't know.
Okay.
It's true, but you cannot choose. You can only choose one of it, but you cannot take two of it.
Yeah, sure. So for example, if you go on plane, right? Have you guys go on plane? Like the steward asks you, you want chicken or fish? You want chicken or fish? Right. You only can pick one. You cannot have both. But sometimes I very how to say I very a bit I ask them for both sometimes. But sometimes they deal with you. But if they say not enough, then they don't give you. Yes, that's right. When you deal with offer, you have this kind of problem. Okay, but then why we don't introduce, why I don't like to introduce this XOR stuff, because it's really coming from the simple thing. Okay, you can actually prove that this exclusive OR, right, is coming from some OR n and negation and n. Yeah, you can check that these two true value is the same. Okay, so when we say that two statement is the same, we meant that their truth table is the same. You guys know how to construct truth table? Yeah. So one exercise you can do at home is take this truth table, work out this truth table. Are they the same under these circumstances? Yeah. You go and compare. It should be the same. Okay, so they are logically equivalent. Have I defined logically equivalent yet? Let me see. Yeah, maybe I can. Okay, we will define logically equivalent later. Okay, but then this remark here, we're gonna prove later. Or as an exercise, you can prove it. Okay. Next is conditional statement. Okay, so if P then Q, okay, if P then Q. So if P then Q, so we are looking for the true part. So when is it true? So, or rather, you can say that when is it false? Okay, so it only false at true imply false thing is false. So true things cannot imply false things. Okay, true can imply true, but false can imply true or false. This is the rule. You cannot ask me why. Because this is the rule that define. Okay, so you have to remember this. This is definition. Okay, so false can implies everything. So that's why I tell you, you cannot remember wrong, or you cannot start with wrong thing, because wrong thing can say anything. So be careful. Yeah, be careful. If you remember, you use a wrong mindset, you can get to anything one. I cannot check you either, because it's always true. So you need to make sure that your step is correct or not. You start from the right thing. Okay. True must end up with true things. But false, I cannot control. Okay, so this is the point of if then. Okay. Okay, makes sense. So if you want to prove something, if then right. If you start with P true, you must prove Q true. This is the direct proof you did in your course. I assume this, and then I prove that this is the direct proof. Okay. But if you don't have P, actually, no need to prove. I don't need to care whether true or false already. It's always true. No need to prove. Cannot prove also. Okay, yeah. Okay, so actually, this line is where your direct proof works. Okay, you assume P and then you prove Q. So you prove P to Q. Okay, yeah. So careful with this. This one very careful because this is where I wanted to say like, yeah, very careful. This is where the society got problem. Yeah, they start with wrong thing, but then they have some wrong implication. Yeah. Okay, so there are a few ways to write down if then. So there are all these same way to write it down. So you can write if P then Q, or Q if P. These are if Q then if P then Q, or P implies Q. You've heard of this? P implies Q. Yeah. So if P then Q. So P only if Q is also if P then Q. Okay. Not the position. Can you distinguish the position? The position is very important. And then this sufficient condition and necessary condition also is very important. P is a sufficient condition, so meaning it's sufficient for Q to happen. Enough. If you provide me P, I can got Q already. But then we'll say Q is a necessary condition for P, meaning what? If I provide you P, Q must happen. Okay, Q must happen. So it's a necessary condition. Understand? So P is like a fuel. It's like fuel. I give you fire, I give you oil, then you will have fire. I mean, if I ignite it, okay. And then Q provided P, so you can think of provided that it's like you see provide, right? P provide you, and then Q happen. Q whenever P, whenever it's like if Q unless not P. So unless it's like there's a negation inside there, so that's why we put not P. Okay. So meaning Q will always happen unless not P. Okay. Next, next we'll tell you about converse, contrapositive, and inverse. Okay. So I want you to recognize the position. Okay. So if we start with P implies Q, what's the converse? I just swap Q and P. Q go back to P. So converse is like, can you go backward? If P can go to Q, can Q go backward or not? This is called converse. Contrapositive is I negate the result, implies a negation of the sufficient condition. So I twist and then I put negation. Inverse then I straight away put negation. Okay, remember? And exercise you could do at home is try to work out the truth table for all these three users. Okay, try and work it out. Okay, so I think I worked out one of them here. Okay. So why do I list this down here? This is very important. So here recognize what is this? I swap position and then I put negation on both. Converse, inverse, or contrapositive. Contrapositive. Okay, I swap position and then I put negation on both is contrapositive. If I just swap, it's converse. If I just put negation, is inverse. Okay, so this is contrapositive. What did you recognize here in this table? You see this truth TFTT is the same. Okay, so this suggests that these two actually is the same statement. Okay, so if you want to say that same statement means what? If you want to say that P implies Q is true, another way to do it is to show that not Q implies not P. Okay, this is a very standard thing we will do in this course. Okay, so we will say that they are logically equivalent. Okay, for two statements to be to be equal, they have to be logically equivalent. Okay, we're going to define that soon. Okay. Lastly, I guess is if and only if. Okay, so this is the biconditional statement. P if and only if. So it would have this biconditional is true when both of them have true value. Okay, false otherwise. So meaning true, 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 or false, false, true. Either one of them is true, false, then it will be false. Correct or not? Because it will violate either one of the direction. Okay. Yeah. Although false can imply true, but then if you go backward, true cannot imply false. So it's false. Okay. So proving if only if you have to go two directions, P to Q, Q to P. Okay. And there we come with a tautology. Okay, so what's the tautology? Actually, it's another statement, but then it's always true. Okay, no matter how you adjust the true value, okay, for your propositional statement. And contradiction is the compound proposition that's always false. Okay, so just now your friend come with P and not P, right? What's your name? I think I need to learn your name slowly. What's your name again? Chi something. Chi. Chi what? Wait. Chi what? What's your name? Chi Yang. Okay, Chi Yang. So just now Chi Yang give an example, right? P and P or not P or not P. P or not P. P or not P. So this is always a tautology. You know how to show it? Okay, so you come up with this table. Okay, P and not P, and then figure out the true value. Turns out that no matter what you do here, it's always true. So this is tautology. Always true one. No matter how you change. I swap, change. I put all the. Do you agree that this is all the possibility I can put? There's no true, right? Because if this true, this has to be false. Yeah. So this false, this has to be no false as well. Yeah. And so, but then P and not P, what do you get? Because one of them is false, it's always false already. So this is contradiction. So contradiction is one of the skill that we need to prove a statement. Okay. If you have a contradiction, then something you can imply later. Okay. So now is it okay? Okay, tautology and contradiction. Yes. Yeah.
What is the
tautology? Yeah. So tautology is a compound statement. Okay, have to be compound, and then there's always true. There's always true, no matter what value, like variables you put.
No. The variable here just means the statement. The PQRX, the statement. Oh, yeah. Propositional variable. If you like, maybe, let me think. Okay, so I guess here I would include something called the quantifier stuff as well, actually. Yeah. Later we will see quantifier, but then for now it's just statement. You can take it as a statement. Let me think. Do you remember in your discrete math, after you learn proposition, you will learn quantifier, like for all that exists, there's a true value there as well, right? So it includes those stuff. But for now, for the purpose now, you can take it as statement. Yeah, you could take it as statement. Like this statement. You could take it as statement first. Okay. Yeah. Something is always false. Can you see? Always false. Because one of them true, the other must be false. Okay, good. Let me see. Do we have times? Maybe we'll left quantified logic next time. But then one exercise you could do is try and prove the De Morgan's law, and then try to prove this. This is very useful for later course. Yeah. So meaning I can write implication conditional statement in terms of negation and only. And this is very useful for proving next time. And then prove that P implies Q is logically equivalent to not Q implies not P. And then this by conditional actually is just putting two conditional together. Do you know how to prove this logical equivalence? How to do? Truth table, yes. Write down a truth table for both and then show that they have the same true value. Okay. Any question before break? Yes. First one, which one? This one? De Morgan's law? This one, first step.
Yeah.
This one. Huh?
The upper one there.
The upper one, yeah, upper one, yeah. Oh, yeah. Sure. You can read in that way. Yeah, sure. Definitely. I mean, like, yeah, you can. But then, I mean, these all things is all of these are the same, actually. Not just these. All of these are the same. But then you can relate that to this. It's fine. It's fine. Because these are equivalent. Yeah. Yeah. So Q unless not P is Q must happen. If Q doesn't happen, not P must happen. Make sense? So that's why not P or Q. Lo. Because you cannot be Q doesn't happen, not P also cannot happen. False or false is false. Okay, so Q unless P would say that Q must happen. If Q not happen, then not P have to happen. Unless not P. Unless it's like 至少是吗？除非OK， 除非not P， 除非 P 不会发生啊？这个除非 P 否则 Q。除非 P 不会发生的话 ，Q。Okay, you listen what I say first. Q must happen. If Q don't happen, not P must happen. 对吗？除非是这样用的，真的。Q 会发生 ，Q 会发生 ，Q 会，有 Q 会。Okay, it's okay. Good, very good. You bring back, go and discuss, and then next class tell me truthfully how to use. Okay, but then what I wanted to say is Q have to happen. If Q don't happen, minus P must happen. Okay, so this is minus P or Q. And Q don't happen, minus P must happen. If both don't happen, then your statement is false. False and false, or false is false. And
yes, yeah, he told me because you compare the Q and not P to the actually.
Unless it's a very weird and redundant word.
Well, I mean, like they use it in this way, so you have to understand their English thinking, yeah. You need to understand their English thinking, yeah. So this is how they think about this. Yeah. It's all not. It's all. So try and relate your true faith to unless. It's a very good idea because I scared you use it in the wrong way. Okay, you have a wrong idea. So try and think about the true fake thing, and tell me next class what's your conclusion about true fake.
And Chinese true fake and our evidence.
Write it down. Yeah, try and write it down, and then we can think about it. Yeah, try writing down the true fake thing. Okay, but this is what I meant. This is what the unless meaning here. Okay. See you next class tomorrow.